Hello everybody, and welcome to Module 1 of our course, Ed Stats. This module is going to give you some of the big picture things. We're going to look at an introduction to statistics, ways that we can display data, and then talk about frequency distributions. And in the end, we will use the data that you've been entering on the Google Sheet to create some of these items that we're going to discuss. So let us begin then by talking about the word statistics itself. Now, the word statistics has a plural and singular meaning. Typically, we probably are using the plural definition of statistics when we say the word. This is simply synonymous with the phrase numerical data. So this is simply a set of numbers that we're referring to. This can be your GPA, number of students proficient on a test, your ACT scores, the shoe sizes of your classmates, etc. Okay, so when we say statistics in the plural sense, most commonly the way we say it, what we're meaning is simply a set of numerical numbers, okay? Numerical data. In the singular form, though, statistics refers to the discipline made up of methods and procedures for studying those numerical data. And so in the singular form, that's our class. And what we're going to be talking about then are the numbers and how we can use numbers and look at numbers, display numbers, what numbers mean. All that is the plural form. So just a little bit of wordplay there for you on that. And then finally, measurement is the process of assigning numbers to objects, events, people, or other things according to a specific rule. And what we're going to see is that we can quantify a lot of things with numbers like height, your GPA, and so forth. And we're going to talk about other ways that we can quantify things with numbers like eye color or your gender, those kinds of things. So we'll get into that too, and how we use that when we're dealing in measurements. Okay, so measurement is simply the process of assigning numbers to objects, events, people, or other things according to the rules that we will create. So what can we do with data? We can organize it. We have to put data in an organized manner so we understand what it is that we are attempting to measure. Whenever we talk about data, we're talking about some form of measurement. That's our ultimate goal. And so we can organize it. And again, that's simply putting it in an organized manner. We can summarize data. Once the data are organized, then we can look back and summarize what we have. A summary just gives a shorthand or an overall picture. When we hear a student has a GPA of 3.01, we do not know the grades that he or she made, but we have a general understanding of GPAs and how they're combined on a 4-point scale or 5-point scale. But generally, we get an idea when a student says their GPA is 3.01, we know what they're talking about. So after we organize and summarize, then we analyze, okay? This implies that we're going to manipulate the numbers somehow. For example, how does GPA from a class indicate readiness for a state assessment? Okay, and this is analyzing the data. So for example, we could look at the grade distribution in an Algebra 1 class and then look at the state testing in Algebra 1 and see what kind of readiness that class prepared those students, okay? We would do that in a number of ways, which we'll talk about throughout our course so that by the end of the course you'll understand how to do that. But that's analyzing, okay? So we're manipulating the numbers to see what kind of relationship is there. And then finally, once we do that, we're going to interpret what we've done. And this is what you will do throughout the course, these steps. Organize, summarize, analyze, and interpret. This is where we give meaningful descriptions and probable conclusions are drawn from the analysis on the importance of the data. So if we were to find that teacher A had a high correlation with her grades and state algebra test, and teacher B had a low correlation with her grades in the algebra test, and we look at the grades and compare the class grades from teacher A to teacher B, what that might tell us then is that teacher B's grades, for one reason or another, we don't know, the data don't tell us this, but those students, even though they're receiving similar grades, are not as prepared to take the state test. Okay, so that's the interpreting piece, and that's really what we're getting at in a lot of this. Okay, so keep that in mind as we move forward. So now we want to look at types of numbers that we're going to use. Okay, and so for example, we can say, what does the number 10 mean? If we just said 10, well, 10 can mean a lot of different things. 10 can mean you're in the 10th grade. It could mean you are the 10th smartest person in the school. It can mean that you are player number 10 on the basketball team. It could mean that you are the 10th best football player on the team. It could mean that your shoe size is a 10, where it's 10 degrees outside. What does that mean if we say 10 degrees outside? So you can see that how we identify the numbers that we're going to use is important. So there are 4 types of numbers that we'll refer to. The first one is nominal numbers. And so when we just say 10, that's a nominal number. And in this sense, it's just a name or a label, okay, that we can add to an individual or group. Nominal numbers are limited in what they can do. Okay, for example, the rank, they don't show rank. Nominal numbers don't show any differences among things. Player 10 on my basketball team and player 10 on the opposing team, there's no difference in just assigning each of them the number 10. And there are no attributes assigned to that. Okay, so some other examples of nominal numbers are simply things like highways, Interstate 44 or Interstate 35, zip codes, license plate, random numbers, male and female, eye color. We're going to talk about assigning numbers to things. And so we could assign males a 1 and females a 2. We could assign eye color as brown a 1, a green a 2, and so forth. Okay, so that's what nominal numbers are. They really don't mean anything. It's just naming or labeling an individual or a group. The next level up, though, we have ordinal numbers, and here we do have some type of ranking according to a characteristic. Okay, it does not measure the difference or show attributes, though, of what we're talking about. But some examples of some ordinal numbers, excuse me, might be percentiles. You know, if you're at the 98th percentile, it doesn't tell us how high you're up necessarily from the 97th percentile, what the differences there are or what the attributes that made you into the 98th. It can, ordinal numbers may show election results, conference placing at sports. You know, Team A can be number 1 in their conference and have a perfect season, and Team B can be number 1 in their conference and barely won with a 7-5 record. Okay, so there's not a measure of difference or an attribute or anything. Ordinal numbers are just used to show rank. The next level up are intervals, and by intervals here, we're talking about the fact that there's an assumption that the distance between the numbers are equal. Okay? So you can see that each of these levels incorporates the characteristics from the previous levels and adds one more. So here, intervals can be used to name or label individual elements, show difference between individuals and some characteristics. They cannot show attributes, okay? And one thing about intervals is there's no zero. So when we say things like 0 degrees, it doesn't mean that there is a lack of temperature. It just means that it's 0 degrees outside. If we say that somebody made a 0 on a spelling quiz, it doesn't mean that they can't spell. It just means that on that quiz they did not get any correct. Okay, so those are the attributes that we're going to see in our last one here. But for now, just know that intervals mean that when we have two numbers, the distance between those two numbers can be assumed to be equal. And so our last one then is ratios. Ratios incorporates everything, and it does have a sense of showing attributes. You can use ratios to understand how tall someone is or how much carpet you put in a room and so forth. For example, if you measure a room and it's 10 by 12 square feet, then you know you need 120 square feet of carpet. Okay, that's a ratio. An interval, the problem, the difference there between the intervals and ratios is there's no zero. Okay, so we're not going to get into that for the purpose of our course, but just understand that there's a difference between an interval and a ratio. And generally the things that we're going to use will be a mixture of a lot of these, and you will start to see as they come out what they are. Your first assignment is going to use a lot of nominal numbers, okay? And we will place those in some data distributions. We'll also use some ratios, okay, in the sense that we're going to look at some characteristics in classrooms, and sometimes we're going to see them and sometimes we're not, okay? So in that sense we'll be using ratios. Variables, so what we tend to do is we tend to tie numbers to variables, okay? A variable is a measurable characteristics. We assign variables to things that we want to measure. For example, when we measure height, we would see the heights of our classmates vary, and we need to assign variables such as h or x or y. X and y are obviously the most common variables that we see. We could assign h to height, and the height would be, 65 inches or whatever. If we measured more than one thing, maybe we measured height, weight, and the age of our classmates, then we could assign the variables h, w, and a to represent the measurements, or we could simply go with x, y, and z. Okay, so variables are whatever we make them, and they help us to measure what we're looking at. So what is the difference in saying the Rangers are 3.5 games ahead of the Yankees and the temperature outside is 43.56667 degrees? The difference in these two things, we understand what they mean, and typically probably what we'd say is the temperature outside is 43 degrees and the Rangers are 3.5 games ahead of the Yankees. But there's a distinct difference in these two numbers, okay? And the difference is the type of variables, whether it's a discrete variable or a continuous variable. The discrete variable would be the baseball games, okay? These variables are used for things such as baseball rankings, okay? They take only the characteristic of the countable number, and they are arranged in discrete intervals such as 1 is a whole number, a third, or a half. So baseball scores or baseball rankings are done in half games. So when we say 2.5 games ahead of somebody, then we know exactly what that means. Okay? Continuous variable, on the other hand, means that there are not those sets within the numbers. So somebody can be 2.5 games. The Rangers can be 2.5 games ahead of the Yankees. If they win a game, they're going to be 3 games ahead. They're not going to be 2.51 games ahead. That's a discrete variable. It only goes in halves. Okay, so they're going to be 3 games ahead. If the Yankees win, it's going to go back to 2.5 games. If the Rangers lose, it'll drop to 2, and the Yankees win, it'll drop to 1.5. Okay, those are discrete variables. It goes only one way. The continuous variable, on the other hand, has multiple iterations, really an infinite number of iterations in between whole numbers. And in theory, continuous variables can be infinitely large or infinitely small. And while we talk about temperature in whole numbers, in fact, temperature could be measured in tens, hundreds, or thousands, or 10,000s degrees. And when you convert temperature to the different scales, you start getting into those degrees. So when we say 65 degrees outside, it could be 65.9975 degrees. It could be 65.5632 degrees. Those things, those infinite numbers that we could carry out, those are continuous variables. Okay, so just know the difference. We're going to stick to discrete variables for the most part that we see. Okay, now just to give you an idea of some criticisms of statistics, and of course we hear these all the time. Anytime you typically go through a PhD program, whatever it is, you're going to have some form of statistics class as you go through. So as somebody who's completed a program, I've heard these ideas. So some people say statistics are anti-individual. Somewhat, yes, to an extent. Typically when we're dealing with single individual cases, we tend to shift away from a statistical analysis and do a deeper qualitative analysis, do case studies or something. But what statistics do the discipline does for individuals, though, is it gives us an indication of probability, which we're going to talk a lot about later on. We have a whole section on probability, that individuals will act in certain ways. Okay, so it's not that they're anti-individual in the sense that we don't deal with individuals. We do tend to deal with individuals. We do it on the aggregate level, though, when we look at individuals in terms of probability. Okay, statistical methodology depends on numbers. Yes. But numbers take on a sense of individuality, or at least toward the individual in some instances. For example, to say that your average wage in your area of employment is $25 an hour depends on numbers, but it's personal to someone who is reading it. And what we're saying here is that, yes, statistics depends on numbers, but the numbers are relative in the circumstances we're dealing with them. Okay, if we say that somebody in Oklahoma is making $8 an hour, then in general we look at that person and see them as making above minimum wage. It doesn't mean they can live any kind of normal life, but that's for another class. That same person in California is probably going to be making $15 an hour. I think California recently went to minimum wage of 15, or Washington did maybe. But depending on where you are in California, the cost of living is extremely high. And so the person making $8 an hour in Oklahoma is probably doing better than that person making $15 an hour in California. So again, statistics does depend on numbers, but those numbers are relative to what statisticians are talking about. The last criticism of statistics deals with statistics can prove anything, okay? And I hear this one the most. This is the most common criticism of statistics. And maybe it's because I hear it the most that it gets under my skin the most, but when people say that statistics can prove anything, there are a couple assumptions made here. First of all, number one, statisticians never use the word prove. Okay, we never prove anything. What we do is, again, goes back to probability. We talk about the probability that something may happen. Okay, so it's all about probability. So we will never use the word prove in this class. The other area, though, that really gets to me is the assumption that the person doing the studying is an unethical person. And so part of what I hope to convey to you as we go through the class is that there is a piece of ethics that comes in dealing with numbers and representing the numbers to the public, especially if you're a leader in a school and you're going to be working with numbers. You want to be ethical in how you present that stuff to the public, your stakeholders. And so if you're an unethical person, then you might say these numbers prove this. If you're an ethical person, you're not going to use the word prove, and you will bring in all the data you can that's available to you, and you will talk about the limitations in the data that were unavailable to you, and then based on the numbers you have, you will give your organization, your summary, your analysis and interpretation, those four things we talked about earlier. Okay, so to recap, the biggest thing here, we don't prove anything, and as an ethical person, you're going to put all your cards on the table when dealing with numbers. So let's talk real quickly about some of the components of statistics. So according to this chart here, you can see that statistics breaks down into descriptive and inferential statistics, and then further on, the descriptive breaks down and inferential breaks down. We're going to look at the difference between those two terms, descriptive and inferential, and what they mean. And then as you see, what we're going to do for the bulk of our class is we're going to concentrate on the inferential side. So let's talk about what descriptive statistics are. Okay, descriptive statistics are simply used to describe numerical data. If we go back to our chart, we see group and individual, and then group is broken down into distribution and summary. So individual statistics shows how an individual did compared to a reference group. Okay, for example, we can show rank or percentile. Here, again, we're talking about descriptive statistics, so we're describing an individual. As far as a group goes, though, we're talking about how we're going to describe an entire set of data. So this might be all the students in your class or all the students in your school or your district. In this sense, we're going to talk about a description of the distribution and a summary of the information. And so what we're going to do for this module is we're going to really hit the descriptive statistics in this module, and then we will move in and again spend the bulk of our class looking at the inferential side. So just to look back at this chart, descriptive is simply describing. So we can describe an individual in comparison to others, or we can describe a group and talk about how numbers are distributed within the group and summarize those. When we talk about inferential statistics, though, on the other side of this, descriptive statistics describe the data you have. Inferential statistics describe the data you do not have. Okay? So all phases of inferential statistics are based on the science of probability. Again, we're going to talk about this later on. So what we mean by saying the data you have and the data you do not have is I can get all the GPAs for the 8th grade students in my school. What I don't have are all the GPAs for the 8th grade students in the county or in the state, okay? And so what inferential statistics will do will help us find those missing numbers from the 8th grade students in the county if we wanted to look at that. So part of how we get those data that we don't have is through sampling. So sampling refers to taking a small sample of a larger group or populations. Statisticians work with samples and carefully locate samples to adequately represent larger populations. We're going to talk a little bit about sampling and how many people do we need to be able to say this is representative of the public and so forth. Okay, they actually have charts that show all that stuff. So under sampling, if we were to go back to our chart, we see under sampling we break down into estimation and hypothesis testing. So again, sampling, taking a small sample of the larger group. So if we were looking at the 8th grade students in my school, then that would be a descriptive statistic, and we would just describe the 8th grade students in my school. But if I wanted to compare the 8th grade students in my school to all 8th grade students in Tulsa County, then I would have to go to inferential statistics. I know what my students are, and I need to take a sample of the other 8th grade students in the county. So sampling breaks down into two areas here. Estimation involves making inferences from samples to the larger population. The results of polls and surveys are a good example of estimations. Okay. And then hypothesis testing uses various statistical methods to provide information about the relationship between numbers or sets of numbers. Statisticians attempt to break through the noise and confusion of information to express reality in an understandable fashion. So what we're going to do is talk about the fact that if I want to look at the 8th grade students in the county, then what I need to do is get a sample of those students. I could survey those students. I could look at county records that are available to the public. I get asked to go see private records and sign forms that say I'm not going to disclose anything. Then we're going to use hypothesis testing, and we're going to see how representative our sample is, whether our sample is just the students that I have or all the students who've reported the test, and try to see if that's characteristic of the population as a whole. And in this sense, I'm defining my population as 8th grade students in Tulsa County. Okay, so we're going to be working a lot with inferential statistics. I know we're throwing a lot of terms at you. If you don't remember the terms, don't worry, you'll get them. Okay, we'll refer back to them, and each time we refer back to them for a while, we will describe them. Okay, so now once we get our statistics and get our numbers, how do we actually represent them? So this is going to be good for you as you move into internship 1 for any of you in school administration, because I'm going to work through some data here to help show you how to do it in Excel. Okay, so we're going to look at different ways to represent statistics. The most common ways here are going to be bar graphs and circle graphs. So we'll talk about what those are and how we do them. Okay, so the first thing here then, a bar graph, some basic rules. All bars need to begin on the same line. All bars should be the same width. Space between bars should be equal. Quantitative scale, your axis, whether it's your X or Y, should begin at 0 point, or an explanation of why you're not beginning at 0. But typically for the stuff we're going to look at, it's going to be 0. Descriptive title should be provided for the graph. Then identify what each bar and each scale represents. So how do we do this in Excel, a bar graph? So let's look at some data. So in our bar graph here, and let me make this a little bit larger. What we have here is a sample of some classroom observations. And what this represents are student grouping, how students are grouped in a classroom. And so you can see we have some definitions here. Large group, student-centered; large group, teacher-centered. Students are doing individual work. Low-level work, students are individual work. This is more high-level work, and so forth. So these are definitions that I've done and created, and so it doesn't matter what it is. What I want you to see here is that this was done in 107 classrooms. Okay. Sometimes things were seen twice. For example, maybe we saw a large group, student-centered work. Students were organized in large groups, but they were doing individual work at a high level. So both of them were marked. So what I've done here is I simply, out of 107 classrooms, we saw student-centered large groups 5 times, teacher-centered large groups 44 times, and so forth. So these add up to over 107 because some of them were in there more than once. I figured the percentage out of 107 classrooms. I saw this one 4.67 times. I saw this one 41% of the time. I saw individual work 23% of the time. So you can see that if we add this up, it's over 100%. That's because, again, sometimes we made things, we reported things twice if we saw 2 things happening in the classroom. So that's why I left that on there. Our total classroom visits was 107. So I want to remove this row. I'll show you why I want to do that. In order to do this in Excel, and I'm not an Excel expert, very minimally done Excel, you need to sort your stuff from smallest to largest. So if you go to the Home tab and go to the Sort filter, we can sort smallest to largest, and we're going to sort. We want to expand the selection, which means we're going to move everything. The reason that we do this is, I'll show you here. So now we're going to select everything. We selected our activity and we selected the percentage it was done. So we're going to go up and insert a bar graph, and we want a horizontal graph. And so there's our horizontal graph. So a couple of things here. The reason that we sorted it from smallest to largest is because when we make the graph, Excel always puts the bottom, whatever the bottom is, at the top. Okay, so we have small to large here. So we have a few things that we need to do. First of all, we don't have a title. This is very confusing down here, and we don't know what these things are here. So we can start by adding axis titles here. Just click on it. This is students activity. Down here, this is percentage of observed during visits or whatever. Our title, student activity. Oh, why is this not typing here? Well, I don't know why it's not typing, but we would change that title to say something like frequency of student activities observed. Okay? Okay, I got it fixed. So what I've titled this is frequency of activity observed. And I have an important thing here. Notice I said n equals 107. That capital N means that this is the number of observations we have. And we're going to use that capital N throughout our course. Okay? So some things that we need to look at. First of all, this stuff down here is too convoluted. So we need to, when we double click on this axis, we can go to Format. We're going to go to Format Selection. And now we can see here our minimum and maximum percentages. Our problem here is that our lines are too frequent. So if we change it to 0.1 or 10%, now we go from 0% up to 50% at our maximum, and we can see much better what's happening. So we'll format that line. The other thing that we want to do here is that we need to either add our totals to the bottom, or we need to add them to the end of our charts. And the way we do that is in Design. So I click from Format to Design, and we can go into Chart Elements. So if we want to add them to the bottom, we can see that. That gets very confusing. So what I like to do is just add data labels to the outside end. Okay, and so now we have a horizontal bar graph. The reason we would use this is because our numbers do not add up to 100%. And so in describing this, we would explain that multiple things could be seen in individual classrooms, and therefore the frequency was noted and our numbers do not add up to 100%. But that is a horizontal bar graph. The next type of representation we have is a circle graph or a pie graph. This I like to use when things add up to a nice 100%. Now that's not a hard rule, but I like to do that, and you will see why that is. So let's go back to our Excel page and look at this. So here's an Excel chart where in 105 classroom observations, what we did is we looked at depth of knowledge that we saw happening in the classroom. And you can see this is depth of knowledge 1, 2, 3, or 4, and we simply tallied those up to 105. And so this is 100%. And what we've done then is simply divided 73 by 105 to get 69.52, 33 by 105, and so forth. Okay, so the representation here, you can present this data, but let's look at what the data show when we make a circle or a pie chart. So we're going to go to Insert. We're going to insert a pie chart. So we can have our pie chart like this. Again, we need to give it a title. So we need to say what we're doing. Now, this in and of itself is good, but what we're missing are those numbers, okay? So what I like to do is get rid of this. Much bigger. Now let's go in and add labels. So if we add these data labels to the outside, and then we can fit our chart in better. Let's see here. There's one. This is a little bit confusing, but oops. You will get a better idea here. So yeah, this is what we want. So we've added labels. Now we need to add percentages. Well, we can just do this. For the sake of what we're doing here, this will work. So this will work. This shows us now that we have 65% of our classrooms observed had DOK 1, 1% had DOK 4, 4% had DOK 3, and 30% had DOK 2. Don't worry about the fact that these numbers changed. We can go in later if we need to and update that. But the goal of this is just to show you how to present things in a circle or pie chart. And the reason we do it is because all these add up to 100%. Okay? So let's now look at a couple more things. So we looked at horizontal information in a bar graph. Let's look at a vertical bar graph. Here, a vertical bar graph, we can highlight our information. Again, if we wanted to put them in order, either tall to short or short to tall, we need to sort smallest to large. Let me take out our heading here because it thinks that's a... We're going to sort this row smallest to large. And notice what happens in this. So this is simply a response to a survey. Let's say we had a response to a survey and we wanted to show how the people responded. We can go into design, and again we can put our responses down at the bottom. We can add numbers, our data labels outside. N equals, let's say we had 200 people here we surveyed. So this is example of a vertical bar graph and how you can take data and create a vertical bar graph. Okay. Let's look at a grouped bar graph. A grouped bar graph is one that you may very well use in Internship 1. And what we're going to do is show scores. So these are hypothetical scores. So in math, we can see that our student scoring proficient in 2016-17 was 45%, in 17-18 was 48, in 18-19 is 53, and there's social studies, science, and ELA. So how can we group these data so that we have a visual representation? So in this bar graph, we had a lot of different things, but none of them were related. Okay, and so because they added up to over 100%, we used the horizontal. In this bar graph, we used vertical. They added to 100%. We could have easily done this and inserted a circle graph and quickly gone and added labels, you know, so that we could see how many people responded, "Do you like me?" In this one, though, we have a lot of data, but we want to group it. So we want to group it by subject and year so that we can see. So the way we do this is very simple. What we're going to do is we're just going to highlight all of our data and our headings. We're going to go to Insert, and we're going to insert a graph. Okay. And let's make it big so we can see this. So this is proficient. Oops. Proficient or better on state testing. Oops. By subject and year. So we know our subjects, math. We can see our years in chronological order. We don't see our scores, so we can go to add chart element. Oops. We need that to pop back up. Okay, I got my chart tools to reappear, so then I click on design. I want to add data label, data labels outside. So the reason it only did it on the ones is because I had that highlighted. But if I go to the whole data chart, now they're all there. So this lets us see, the reason this chart is important is because it lets us see over time how each individual area is doing. So if this is, maybe this is a specific grade for 9th grade. Now the bad thing about this is not trend data. This is just showing how the 9th grade students are doing in these subjects. But typically we can look and see that science is doing pretty well. English did okay. In 2017-18, the English scores dropped for the 9th graders, but they went back up. Math and social studies are not doing well. So that's an analysis real fast. Then our interpretation would be, why are they not doing so well? One thing you can do here that I want to show you is if we say we want to select data, we can flip these X and Y just to show you what that looks like. Again, what we see here now is we see the 3 years and the subjects. So this clearly lets us see what subjects are doing well. Personally, I like this other XY alignment better. So we can see individual trends within the subjects. Okay. So the last thing I want to show you is what we call a stacked bar graph. And a stacked bar graph would be used if you had some surveys and you wanted to compare some responses. Okay, so let me show you what I mean by that. So let's say we have this these questions dealing with differentiated instruction. So we ask teachers these 4 questions. I have the knowledge, tools, and support to effectively differentiate instruction. Strongly agree, agree, strongly disagree, or disagree, strongly disagree. So we can do just this, since we know this adds up to 100%. And we see that we would define these so that between 56, between the blue and orange, we would clearly see that most have either strongly agree or disagree. That's how it would look in a pie chart, okay? But what we can do here is highlight our questions. There are other questions. I've received adequate training in how to successfully differentiate instruction. My classroom instruction meets the needs of all my students. If a teacher is successfully differentiating, then the needs of all the students would be met. And the last one, differentiation is necessary for my students' needs to be met. This is their belief that they need to differentiate in order to meet the individual needs of their students. So what we do now is we're going to go to insert. We want to insert a chart. So this would be our chart. So let us do some exchanges here real fast. Select data. So the first thing I'm going to do is I'm going to flip this. And now we see a better representation of what we have. Okay, this is the question, and then this is the response. So we would, instead of series 1, 2, and 3, let's format this. So select data. Series 1 is actually strongly agree. Notice what happens there when I change it. Series 2, you can just edit it by this way as well. Series 3 and Series 4. So now we have a better idea. We've got to give it a title, teacher. Let's say this represents 150 teachers. Okay, we always got to give our N number. The only thing we're missing here are the actual numbers. We could either add them to the bottom. Personally, I don't like that. I think it gets confusing. What I like, personally, is again adding them to the actual chart. But what happens here is that we have to go in and individually move them outside so that we can see them. And in Excel, this typically, they want to be placed in the middle of the color. Okay, so we would do this for all of these individually. Again, it takes just a second to do it, but what happens now is that we can see the responses from our teachers to these questions. So this is a stacked bar graph. We're doing this one horizontally. And so now we can see that differentiation is necessary to meet my students' needs. 98% of the teachers agree that this is an important thing. Okay? But it's interesting when we look down, they believe this is the case. But now the next question, my classroom instruction meets the needs of all my students. 87%, only 87% said that's the case. So while 98% said they believe that differentiation is important, only 87% said that their instruction actually meets the needs of the students. So this is just interpreting, and then we would analyze and say, okay, so what is this telling us? We can go on and the rest of these questions, and typically what we're going to find out is they think it's important, but they just don't know how to do it. Okay, but this gives you an idea of how to do the different types of charts in Excel and why you might use them. This stacked chart, I typically use this when I have questions that I want to compare specific question and responses to each other. So you can see all these questions are in a group. The answers out here all add to 100%, and I've broken it down on the actual bar whether they strongly agreed, disagreed, or strongly disagreed. Okay, and then we can take all this and analyze it and interpret the meaning of what this is and reflect upon that as administrators and how we could address what we found out. So let's go back to our presentation. So the two main ways that we will present information is in bar graphs and circle graphs. The only other thing I want to give you here is frequency distribution. This is the last thing, to take a few more minutes here. Frequency distribution talks about how we organize or display our data. Okay, frequency distribution just helps us get a better understanding of visually what our data are saying. And notice I used the plural of data. Data is a plural word. The singular form of the word is datum, D-A-T-U-M. Most people do not get that. I can promise you in your internship that will be picked up on. So make sure you realize that data are plural. Datum is singular. So one way that we display our data is that we put them in frequency distribution. So let's take some numbers that represent speeds recorded at a 55 mile an hour speed limit sign. So let's assume we were standing at this sign and we had these 15 cars come through and we recorded the speeds of each car. You can see the speeds are just randomly done here, okay? So frequency distribution then tells us, it gives us a better idea of what we have here. So you can see the speeds 58, 53, 50, 56, all the way down to 41, all the way up to 60. So one way that we can do a frequency distribution is simply a tally. And we can put our individual speeds here and then put some tally marks out to the side. And you can see by looking that we have a few who are fast, we have a few who are slow, but we have a lot right here in the middle. Okay, not a surprise. That's a tally, just including the first column, the recording, the second column, the frequency or number of times something happened. We can also do what is called the group frequency distribution. And here we're taking those same data and we're organizing them into larger groups. So you can see we've broken our groups. Instead of individual speed limits, we've just made groups. So here we have 57 to 60 miles an hour, we had 2 occurrences. 54 to 56, we had 3. 51 to 53, we had 7. 41 to 50, we had 3. So if we look at this, we see, yeah, they're kind of all in the middle, with some fast and some slow. But actually, when we look at this, what we see is we get a little bit better of an idea that at 55, we had 10 of them that were below 55, and maybe more because this starts at 54. We only had 5 out of the 15 who were going 54 or faster. So that gives us a little bit better idea of our frequency distribution by the way that we see these numbers here grouped together like this. So these last few slides are just going to take that frequency distribution and extend it out. So the first one we have is what we call our cumulative frequency. And what we do is we simply start at the bottom. These are the same numbers we had on the previous table. And so our cumulative is we're going to add from the bottom up. So we had 3 in 41 to 50. Our cumulative total is 3. We had 7 in 51 to 53. Our cumulative total at this point is we're going to add everything from 7 down, becomes 10. 54 to 60, we had 3. We're up to 13 occurrences. And then finally 57 to 60, we had 2. We're at 15 occurrences. Okay, this is going to be important, and I'll show you why in a minute. So next thing after cumulative frequency is the relative frequency. And what we want to see here is how often are we seeing these groups being represented. So in other words, if we see 3 cars and the 41 to 50, then what percentage of the total is that? And so you can see here our formula is our relative frequency equals our frequency divided by our big N, and our big N here is 15. So we just take 3 divided by 15 and we get 20%. 51 to 53 we had 7. Our cumulative frequency was 10. If we want our relative frequency, 7 divided by 15 is 47%. So we're getting an idea of how the data are distributed by simply looking at the relative frequencies here. 20% fell in the 54 to 60 range, and 13% fell in the 57 to 60 range. The last thing that we want to look at is our relative cumulative frequency. And basically think of this as kind of a percentile, okay? And I'll show you what I mean by that. So whereas we did our cumulative frequency by adding everything below, we're going to do the same with relative frequency. And so when we say that 20% were in the 41 to 50, our relative cumulative frequency is 20%. But when we say that 47% or 10, seven occurrences were between 51 and 53. Our cumulative frequency is 10. At this point, when we figure it out, what we have is our relative frequency is 47%, but our cumulative frequency now is 67%. So we can see that we clearly have 2/3 of our occurrences happening. Our cars were rated between 41 and 53 miles an hour, 2/3 of them. So this is telling us that in general, people are slowing down when they see that 55 mile an hour speed sign. We would just continue. Cumulative frequency of 13 here, 13 divided by 15, 87%. And then finally, our cumulative frequency, we had 2 occurrences in the first interval. That was our total occurrences. When we accumulate them, we add our relative frequency to all those below, and we get a total of 1. Okay? So we're going to use this same method later when we look at the percentile rank in class and get this. And basically what we're saying is we're looking at relative cumulative frequency to determine percentile. So we'll come back to this, okay? Last things, how are we going to represent a visual representation of our data? So using those same speed limits recorded that we looked at in those 15 incidences. The first one is a histogram. We talked about the bar graphs and so forth. This is just another phrase that we use for data. So here we can see that we had 3 occurrences between 41 and 50. We had 6 occurrences between 50 and 59. And we had 1 occurrence between 50 and 68. I think the data are a little bit off there because we had more than that, but that doesn't add up to 15 is what I mean. But what you see is a histogram, and so we get a clear indication that from looking at this, that most of our speeds were recorded in the 50 miles an hour. A frequency polygon, this is telling us the frequency of something happening, whether it was 1, 2, 3, or 4 times. We had nothing at 4. And these are all of our midpoints or actual speeds recorded. We had 1 at 41, 1 at 47, 1 at 50, 1 at 51. Then we can see we jumped up to 1 at 50, or 3 at 52, 3 at 53, 2 at 55. It would be right there, and then 1 at 56. Again, it's a visual representation of our data. And the last one here I want to show you is a scatter plot, and this would be if we had another variable. And we're going to refer back to this later on in the course, but let's say we added another variable and we wanted to look at the age of our cars. And so by doing that, if we looked at the age of our car and used that as our y-axis, and looked at the speed of our car and used that as our x-axis. So our car that hit at 41 miles an hour was rated as 15 years old. The car that hit at 47 miles an hour was rated was 5 years old. And so forth. You can see the car that was at 56 miles an hour was 6 years old. The car that was going 58 miles an hour was 2 years old, and the car that was going 60 was 1 year old. This is an important representation of our data, and we will pick scatter plots up later on, but I just wanted to show you that and introduce you to that. What you are going to do now for the assignment is you have been inputting data in the course to just general data about the school or about our class. What I'm going to ask you to do is to take some of those data and make a circle graph and a bar graph in Excel and submit that. Okay? So overall, again, an introduction to statistics, basic idea of numbers, how we categorize numbers, what we do with those numbers, organize, summarize, analyze, interpret, and then how we display those numbers, whether they're in bar graphs, circle graphs, histograms, scatter plots, and so forth. Okay, so we're going to move on into our next module in a few days, and in that module we're actually going to start talking about how we make sense of the numbers that we get. So you're going to see numbers representing characteristics of students in our class. How are we going to make sense of that? And we'll do that in our next module.